Right now we're going to look at f of x equals e to the x, which is the parent function of the exponential function family. So before we get into that, what is e? Well, e is a number. It's a transcendental number like pi, and e is approximately 2.718 dot 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 dot. There are a number of official definitions of what e is. One definition of e is to take 1 over 0 factorial. So that would be 1. And then 1 over 1 factorial, so that'd be 1. And then 1 over 2 factorial, that'd be 1 half. And 1 over 3 factorial, that's 1/6. And then 1 over 4 factorial, that's supposed to be 4 factorial, not a 41. And then 1 over 5 factorial, and then 1 over 6 factorial, etc. If you keep going, this infinite sum adds up to approximately 2.718, and that number that it adds up to is defined as pi. Why do we use this number? Because it leads to a lot of special properties when we look at the slope of this. It will mean more in calculus, but this is a valuable number. And it's not as obvious that it's just as important as pi, because pi is more fundamental to geometry than e is to algebra, but e is very fundamental to calculus. So what does f of x equals e to the x look like? Well, it's an exponential function. It's an exponential growth function. Just like all exponential functions, the domain of the exponential function is all real numbers. So all real numbers is the domain. The range, well, no matter what you plug in, you'll always get out a positive number. You're never going to get out 0 or a negative. So the range is y is greater than 0. And you can see that from here, it goes from 0 and it goes up. This is going to, on the left, it's going to get closer and closer to 0, but never quite touch it. The x-intercept, well, this one doesn't have an x-intercept because it never quite touches. The y-intercept, when you plug in 0, 0, e to the 0, just like anything else raised to the 0th power, it's 1. So we have 0, 1 is our y-intercept. And our end behavior, it goes up and to the right, which is pretty clear here. And then on the left, it is going down, but it's not going down to infinity. On the left, the asymptote is y equals 0. So we have a horizontal asymptote at 0 that it gets closer and closer to. So if you plug in a negative number, like e to the negative 1000, you get something that's really close to 0, but is still bigger than 0. So it is up and to the right. That's not me pointing at the word asymptotes. The end behavior is up and to the right, and the only asymptote is y equals 0.